All right, today we're going to do the first of our three nutrient cycles. So the three that we're going to focus on are carbon, nitrogen, and phosphorus. We're going to start with phosphorus because that's the simplest one, and I'm going to try to be able to draw the carbon and nitrogen ones when we get there. So first off, just to talk about the importance of these nutrient cycles, one thing to remember is that just like our laws of thermodynamics, it tells us that energy can neither be created nor destroyed, neither can matter. And so all the nutrients we have on this planet were here when we started, and they just change forms. They're going to be in the atmosphere, they're going to be in the soils, they're going to be in living things, they're going to be in water. But we never run out, we just recycle those nutrients. So what we'll focus on with these nutrient cycles is how they do cycle through these different areas of our biosphere. So there are many different elements, but there are six that we think are most important to life functions. And so we call those the big six. And the ones that we focus on in class are what we have abbreviated as NCHOPS: nitrogen, carbon, hydrogen, oxygen, phosphorus, and sulfur. Now, we've actually already talked about hydrogen and oxygen when we talked about the water cycle when back in Unit 2. So with water, we already know that that cycles through evaporation, precipitation, going into the groundwater, and back into our atmosphere. So we've already done hydrogen and oxygen. We're going to not focus on sulfur, but we are going to focus on nitrogen, carbon, and phosphorus. So one of the big reasons I want to start with phosphorus is because it's often known as what's known as a limiting factor. And what that means is that it's that one thing in nature that is lacking, and it is not allowing things like plants to overgrow. So there are often things that are limiting in nature. Now, a lot of times in saltwater ecosystems, nitrate is limiting, meaning they have enough phosphorus, they have enough carbon, everything else for natural processes to go, but they just lack nitrogen. Phosphorus is often limiting in freshwater. You'll often also see phosphorus limiting in things like soils and agriculture, because as we're going to see, phosphorus cycles very, very slowly. So this is a diagram of the phosphorus cycle. Now, one thing I want you to notice is that there's no section up here in the atmosphere. In our carbon and our nitrogen cycles, we will start in the atmosphere because that's an important key reservoir for those nutrients. But for phosphorus, there is no gas phase. Now, phosphorus is a limiting factor for a lot of things, and all living things need phosphorus. So phosphorus for us is part of a big component of your bones and your teeth. It's also part of ATP. If we break that ATP down, it's adenosine triphosphate, so it's 3 phosphate groups. Also, it's in every molecule of DNA. If you remember your DNA structure, it's got deoxyribose, it's got the nitrogen base, and it's also got a phosphate backbone. So every living thing needs to have phosphorus. So it does have to cycle through our ecosystem. It just doesn't have a reservoir in the atmosphere, and that makes it very, very slow. So probably what I'll start with is the phosphorus in rock. So phosphorus is often stored in soils or rock. So when it's exposed to the atmosphere, what can happen is weathering. So if you guys remember weathering, that's the chemical and physical breakdown of rock. So first that rock has to be weathered in order for the phosphorus to be accessible for soils, for plants, and then its way into living things. So once it's in our soils, it can then be exposed to erosion. It can make its way into our waters. So one of the things about getting into our waters, if you remember that phosphates are one of our key nutrients that, because it's limiting, when it's added into our water systems through runoff and erosion, will often lead to eutrophication. But once it is in our soils, then what that means is it's able to be picked up by plants. So that's going to be our first step for all of our nutrient cycles, that it has to be in the soils so it can be taken up by plants. So these are our primary producers, and once it's in our primary producers, it can get into our herbivores. So it has to get into plants first, and then it can get into all living things. Now, living things will contribute back to the phosphorus cycle through waste and decomposition. So all of the dying and decaying plant and animal material will allow for that phosphorus to get back into the soils through decomposition, where it can then be formed into rocks again. And so this is a pretty simple cycle that's driven by weathering and erosion, so that we can have rock formation. The rock becomes exposed through plate tectonics. It becomes exposed to light, to air, to rain, to wind, to plants that allow that rock to weather or to break into smaller pieces. That allows the phosphorus to get into the soils, where it can run off into our waters, but also it can be absorbed by plants that need it for their functioning. And then we get our phosphorus from the food that we eat. And then we all contribute back to the phosphorus cycle through death and decomposition, where it gets back into our soils, and then it forms into rocks again. So this is why this is such a slow cycle. One, that there's no air component to it, and two, it's relying on the physical buildup and breakdown of rock, which is on the geologic time scale. So one of the big things that you're going to have to possibly talk about in your AP test is how humans impact the phosphorus cycle. So one of the big things that we do is we do mine phosphate rock for fertilizers. We can know the rocks that are heavy in the phosphate concentration, and so we can mine those phosphate rocks so that we can pull that phosphate out for products and for fertilizer. Also, phosphates are stored in trees because they're going to be using that for their DNA and for their structural components. And so when we cut down things like rainforests and old growth forests, we take that phosphorus away, and it's not going to be available for herbivores. It's not going to be able to be decomposed into our soils. So when we take those trees out and we build products out of them, then we're essentially saying, okay, this phosphorus is no longer able to be cycled. And then some of that phosphorus that we mine and then we manufacture, we put into our fertilizers. And then that's actually adding excess phosphates in some areas where we don't need it, and that's going to lead to eutrophication. Now, one of the big things that I want you to start thinking about are links to other units, because I think this is how that those FRQs are going to be based for your test on May 18th. That you're going to have to be able to find those links. So here with the phosphorus cycle, what I was thinking is that there's a real logical link to agriculture, because phosphates are often a limiting factor. They are a big component of our fertilizers. So the reason why we need to add this again is because that speed of the cycle. The phosphorus is slow, and that often it's limiting, and so we put it into our plants to allow them to grow faster and to grow bigger. Also can be tied to water quality because of that eutrophication. So because phosphorus is often limiting, particularly in freshwater ecosystems, the addition of phosphates in the fertilizer can go into our waters, lead to those algae blooms and the death of animals and loss of biodiversity due to the lack of oxygen. I think it also can tie to our mining unit because we do mine for phosphorus. So when we talk about mining, all the impacts of mining, such as habitat destruction, the use of heavy machinery that uses fossil fuels, that leads to the air pollution. So the mining component could come into play, as well as geology, because this cycle is so based on weathering and erosion. So I think some of those key geology concepts could come into play, allowing that phosphorus to be free to be picked up by our primary producers and then their pathway into our herbivores. So that is actually it for our phosphorus cycle. This is going to be our quickest one. It's going to be our easiest one. And like I said, for our future ones, I think I'm going to try to find a way to show me drawing it, because those steps are a lot more complicated and there's a lot more links that we can make. So I'm going to play around with that a little bit. but this one was a pretty good and simple introduction to it and the importance of these nutrient cycles. So I think these are key concepts that really might be addressed in those FRQs, because this is kind of like the basic, which is why I leave it till the end of our year so we can start to make those links. So that's what I want you to be thinking of when you're reviewing these nutrient cycles. So put any questions in the comments below, and we'll cover those in our face-to-face session.